to working successfully with the engine. So Bioshock. We started with a very early version of I guess the Unreal 3 code on that project. It was pretty much in between Unreal 2 and Unreal 3. Early on, when features in Unreal 3 sort of weren't really complete yet, we would just dive in and basically write our own versions of those features, and we pretty much just throw out any of the work that Epic had already done in UE3. So we basically rewrote a lot of stuff, from the renderer to the AI system. And to begin with, we thought this was a really great idea, and we were sort of patting ourselves on the back. And you know, in sort of the first half of the project, we could actually make the claim that our modified engine was more feature complete and more optimized than Epic's version, than the base Unreal 3. But in the final half of the project, it really came back to bite us quite badly. We found that we'd done so much custom stuff that it was actually impossible to merge all the new features coming online in Unreal 3 back into our code base. And so we reached the point where we needed a bunch of features to actually ship Bioshock on time, but we were and those features were working and fully done in Unreal 3, but we were unable to get them back into our code base. And so for a lot of those features, we had to just basically bite the bullet and re-implement them from scratch in our own code base. And you know, this wasted a huge amount of time and also got pretty demoralizing for a lot of the coders. So I'd say that in the end, we spent so much time in the latter half of the project playing catch-up on all these Unreal 3 features that by the time we shipped, in terms of technical feature set, we'd actually fallen well behind base Unreal 3. So in our current project, we're taking a very different approach. The aim is to keep fully in sync with the base Unreal engine. Any features we add, we think about very carefully, and we make sure that they're clearly separated from the core Unreal code, either through sort of good OO design, or in the worst case, hash defines down in the code base. This actually adds quite a lot of complexity to coding tasks. Coders now have to think not only about how to design the systems sort of to meet the requirements that we have, but also how to design them in a way that has minimal impact on the core engine. Having this minimal impact is actually a top priority for us, to the point where when we're designing a system, we'll often go with a more time-consuming solution if it means that it's less invasive to the sort of core Unreal code base. So the big benefit of all of this is that we can relatively cleanly merge in the new versions of the engine. As Jay mentioned, they come out every 1 to 2 months, and generally every 2 to 3 months we will pull the latest versions into our code base. It still takes a fair amount of both QA and coder time to do these merges, but compared to the amount of time it would take us to sort of implement the features and bug fixes we're bringing in ourselves, it's really an insignificant amount of time. So overall, this is working well so far, and we've managed to keep fully in sync with the base Unreal code base, while still maintaining our own set of additional technology features on top of that. So finally, some gotchas. As it should be clear by now, you need to really plan carefully how you do additions and modifications to the code base. If you just go hacking code straight into the base engine in the way we did in Bioshock, you'll get into trouble. One aspect of this is what we refer to internally as doing things the Unreal way. And basically it means don't go messing with the base Unreal code just because you think they've done something in a silly or non-conventional way. We actually find a lot of coders have big issues with this. I think it's a coder thing to always want to go in and rewrite other people's code because you can do it better or design it better or whatever. But you know, it just leads to trouble when it comes to merging in new features later on down the line. And this is something we have to continually hammer into coders and really keep an eye on during development. So even though you're licensing an engine, you'll still need a good technology team to maintain all this stuff. Additionally, I think a lot of people assume that licensing Unreal makes it a no-brainer to do console ports. But really you still need good technical people to do with all the console-specific memory, load time, performance optimization stuff. Especially on PS3, no engine is just going to magically make your game perform optimally. So I've mentioned that the content tools are very powerful. They can let your art and design people do a lot of cool stuff. It also means they can do a lot of really, really bad stuff that really can bring the game to its knees or introduce really hard to find bugs that are quite complex to debug. A lot of these tools, like the scripting and material system in Unreal 3, actually sort of tread the line between technical work versus content work. And so what we find is we actually need to have coders sort of cast a technical eye over some of the work that the content people are doing and just sort of suggest potentially simpler or better ways to do things. So finally, UE3 is a massive code base with a huge number of features in the tool set. It can take many months for people to get up to speed and learn how to use them all. And when it comes to the code base, it can literally take the lifetime of a project for people to really become experts on the code and sort of know it inside out. So what this means is if you're working on an Unreal project, people with Unreal experience are incredibly valuable. And you really need to make sure that you hold on to them and have ways for them to pass on their knowledge to other members of the team. And that's it. Back to Jay.
It's not all fun and games. So let's talk a little bit about use of middleware as well, specifically Unreal Engine outside of the game space. As part of our games, we're all making these rich cinematic experiences that help drive the narrative along. And what we found in the development of Unreal Engine is that we've developed tool sets that allow people who are making linear story product, television, commercial, and in some cases theatrical product, at a faster pace and at a much lower cost than it's taking them to use their current pipelines. And so the tool that we have inside our tool set is called Matinee, and it's a very rich multi-track linear cinematic editor. It's sort of like having Final Cut Pro or Adobe Premiere inside the game engine, allowing you to take control over every aspect, all of the cameras, all the particle effects, everything. And we've even gone in and the programmers have set it up so that certain things like particle effects and physics pieces have deterministic applications. So that when you blow a building up, for example, in a cinematic, if it's just a physics approach, you can never guarantee where chunk A is going to fall because it's just a physics piece and it's just going to go flying and it's going to react in the world. But if you're making a linear story, it's likely that you want certain things to happen in a certain way every single time that you run it. So we've gone in and we've made that happen, so that way you can scrub forward, scrub back, particle effects, things that require a deterministic aspect, you can set in place, and you know guarantee that every time it runs, it'll act that way.